Good day. In this video, we are going to study about what is capacitance. What is capacitance? Capacitance is defined as the ability of a device to store energy in the form of electric charge. So the electronic components which stores energy in the form of electric charge is called capacitance. The unit of capacitance is farad. 1 farad is equal to coulomb over volts. A capacitor consists of two conducting plates separated by an insulating material called dielectric. In this diagram, we can see that a capacitor is having two conducting plates which is indicated by green color. The first one is positive charged and the second plate is negative charged. The gap between these two conducting plates is filled with dielectric. So the dielectric can be air or it can be any type of insulator. The positive plate is connected to the positive lead of the capacitor and the negative plate is connected to the negative lead of the capacitor. The capacitor value depends on the dielectric constant of the substance separating the plates and surface area of the plates. So the gap between the plate may be small letter d and the surface area of the plate may be S dot A. So this sizes, that is the surface area of the plate and the gap between the plates, determines the capacitance value. That is, the capacitance is directly proportional to the surface area of the plate and is inversely proportional to the separation between the plates. The capacitance value increases if the surface area of the plates increases. That is, the capacitance value will increase if the surface area of the plate increases. The capacitance value will decrease if the surface area of the plates decreases. Similarly, if the gap between the space, that is the capacitance value, will increase if the gap between the plates, that is the distance d between the plates, decreases, and also the capacitance value decreases if the distance between the plates increases. So that's why the capacitance value is directly proportional to the surface area of the plate and it is inversely proportional to the separation between the plates. The working of a capacitor is illustrated with the water tank. Here we have a water tank with an inlet and an outlet. The inflow of the water to the tank is controlled with the help of a water tap. Let's consider the water tank as the capacitor, inlet as the power supply, and the outlet as the load in the circuit. Initially, the inlet tap is open, so the water starts flowing and the water level rises in the tank. And also there will be an outflow of water from the tank. So let us compare this with the capacitor. When the circuit is supplied with power, the capacitor stores the electrical energy and also the power passes through the components in the circuit. So the capacitor will store the energy and also this power will be supplied to the other components in the circuit. So the next scenario is when we close this tape, what happens is there won't be any inflow of water to the tank. So when the inlet tape is closed, there won't be any inflow of water, but there will be outflow of water until the water in the tank completely drains or until the water level goes below the outlet level. So the water starts draining through the outlet. If we compare this with the capacitor, if the power supply is switched off, the power in the capacitor starts discharging and will be supplied to the circuit until the capacitor completely drains or it is completely discharged. So this will be the condition. The inlet is closed, so all the water from this tank has escaped through the outlet. Similarly, if you compare this with the capacitor, when the inlet is closed, that is when the power supply is switched off, all the charge in the capacitor will be supplied to the circuit for a particular time, and after that, when all the charges has escaped, it cannot supply any power. This is how the capacitor stores energy. The internal structure of the capacitor is shown in this diagram. We can see the conducting plates and the dielectrics are rolled in this manner and placed inside an aluminum case. This is the aluminum case which is insulated. So we have the metal plate 1 and the metal plate 2. In between you can see there is a dielectric which is being rolled and placed inside the aluminum case which is insulated with plastic. Then the conducting plates, that is the positive and negative terminals, are connected from these plates, that is the metal plate 1 and the metal plate 2, that is metal plate positive plate and the negative plates, so that you can connect this to any port of the circuit. What is capacitor? Capacitor is a passive electronic component that stores energy in the form of electric field. So images shown here are different types of capacitors. The capacitors are used in different circuits and in motors. In the circuit, the battery is connected to the LED through a switch, a resistor and a capacitor. When the switch is closed, the LED will glow and the capacitor charges. When the switch is opened, the battery cannot supply power to the circuit. So the capacitor discharges and the LED glows for a short duration. The LED will glow until the capacitor discharges all the charges. This is the simplified form of the circuit when the switch is kept open. When the switch is kept open, the battery will be open circuited. So the battery won't supply any power to the LED. So we can remove the battery from the circuit. So this is how the circuit will be when the switch is kept open. The symbol of capacitors are shown below. There are three symbols. The first one is fixed capacitor, the second is polarized capacitor, the third is variable capacitor. The formula to calculate capacitance is C is equal to Q over V, where C is capacitance, Q is charge in coulomb, V is voltage in volts. Uses of capacitor. The capacitors are used to synchronize voltage and current in a circuit, used in rectifier circuit, that is AC to DC conversion, used to store electrical energy. The first use of the capacitor is to synchronize voltage and current, that is power factor correction. In this graph, you can see that the voltage and current are not in phase. That is, in a circuit, if there are too many inductive loads, the current and voltage won't be in phase. That is, current will be lagging behind the voltage. So in order to rectify this, we can use a capacitor. If we use a capacitor, we can synchronize this voltage and current so that at the output you will have the voltage and current in phase. So we have used a capacitor. So because of that, the voltage and current has synchronized and they are in phase. This is one of the application of capacitor. The second application is it is used in rectifier circuit. The rectifier circuit is used to convert AC to DC. So the AC input is a sinusoidal waveform. When it is rectified, you will get a half waveform with ripples, that is, it has noises. To get the actual DC output, we'll use a capacitor to filter it. So when we are filtering it, we'll get an output like this, that is, these ripples have been removed by the capacitor. So using the capacitor, you can filter the DC output. That is, you can remove the noises and we'll get the actual output. This is another example for capacitor's application. How to identify capacitor value? The capacitor values are mentioned in the capacitor. Here is an example. A capacitor is shown here. The value of this capacitor is 47 microfarad and the voltage rating is 450 volt. We can also measure the value of capacitor using multimeter. Thanks for watching this video.